Couple things we need to know about 11.2 is there are 3 types of polynomials. The first type is called a monomial. The monomial is a polynomial with one term. So an example of that would look just like 7x to the 6th. What would be the degree of this? 6. And the leading coefficient? 7. Very good. The second type is called a binomial. And this is a polynomial with how many terms? 2. Example would be like x cubed minus 11. And hopefully you guys realize that a term means that something separated by an addition sign or a subtraction sign is what a term means. And the third type is a trinomial. And that is a polynomial with 3 terms. All right. Example 1. A piece of metal (15" by 20" is made into a box by cutting out square sides x of each corner. And the question is, let V of x be the volume of the box. Find a polynomial. Formula for V of x. Now, I don't know if any of you have ever created a box out of a piece of paper or out of cardboard. But if you take a piece of paper or your cardboard, and literally what they're doing is they're going and they're taking and ripping out the corners of each side to create your box. And what they're going to do, so if you take out your corner pieces, then that's where your box is going to come into play. And that's how actually, if you look at the boxes, that's how they're kind of constructed. And that's what it's saying to do, is it's saying to take out a corner piece, and this is just an example, so it's not completely good, but that's what we're making, is we're making the bottom of this box. And we're going to be cutting out these corner pieces, is what we are doing. So, what we have is we had your piece of metal, and it was 15 by 20, and we are cutting out the corner pieces x in width. It's going to be a square that we're cutting out. So each one of these are all x's, that because they're squares, just so you kind of can see what they are. So we are looking for what the volume of the box, once we fold it up, what the volume of that box is. So when we fold this bottom box up, remember this is going to be gone. It's going to be, so this is going to be the length of the side, and then I can kind of, we'll draw it like this so you can kind of see it. So this length right here, it comes from here. So how much, what is this length right here? It was 20, but what did we take away from it? We took away x here and an x here. So this is really now what? 20 minus 2x. Right? So it was here, and then this was 20, and we just took away an x and an x. So this part is your 20 minus your 2x. Then we took, and we're taking, this side was 15, but we took away an x and an x. So now what is the other side of the box? What is this length of the box? 15, yes, 15 minus your 2x. And what is the height of my box? Hopefully you guys can see it's what I took out, right? It's that x. So my height is x. How do you find volume of a box? What is it? Yeah, so your length, your width, and your height is right. And so you go 20 minus 2x times 15 minus 2x times x. So the first one, hopefully you guys remember to do, you would FOIL. So you would go through and you'd FOIL that. Grab my clippers. So we have our 20 times 15, 300, minus my 40x, minus 30x. Negative is positive. 2 times 2 is 4, x squared. And I'm still leaving my x on the outside. And remember that this is your volume is equal to that. Combining like terms, I have 300, 40 and 30 is your 70x, plus 4x squared, and I have an x on the outside. When I have an x on the outside, what do I have to do with this? I have to distribute it. I have to multiply this to everything. So I have here 300x minus 70x squared plus my 4x cubed. And volume is still equal to that. One last step. When I am writing my polynomial, what do I have to do? What do you think I have to do with this? Put what? Very good, the largest degree in front. So I have to rearrange this so it goes largest to smallest. So my final answer is v of x is equal to 4x cubed minus 70x squared plus my 30 or 300x. What is the degree of this polynomial? 3. Leading coefficient? 4. Very good. And what type of polynomial is it of the 3 terms we learned? Trinomial. Yes, very good. Because there's 3 terms, so it's a trinomial. All right. Second example, last example. Expand 5x squared minus 4x plus 3, and I'm multiplying it by x minus 7. All right. When you have a trinomial and you are multiplying it by a binomial, you have to remember that you have to take this term and multiply it by each one of those. Then you have to go to your next one and multiply it to each one of them. And then your final one and multiply it to each one of them. You have to make sure each one gets multiplied together. So I'm going to take the 5x squared and I'm going to multiply it by x. Gives me 5x cubed. Then I'm going to take 5x squared and multiply it by a negative 7, which gives me a negative 35x squared. And then I'm going to take and go to my next number. Negative 4x times x gives me a negative 4x squared. 3 times a negative 7 gives me a negative, no, that was a negative 4, no, negative 4x, and so it gives me a positive, actually, because I didn't say it was negative. Negative 4x, and that gives me a positive 28x. And then my negative 4x is done, because I have both of those. And then my last term is what? 3. So I'm going 3 times x gives me 3x. And 3 times negative 7 is a negative 21. Combined like terms. So I'm going to combine like terms. I have 5x cubed. And I have negative 39x squared. 28 and 3 gives me my 31x minus 21. Alright, I want you to take a moment and do what you did yesterday and see what are these things. What is a sub 3? What is a sub 0? And what is n? I want you to see if you remember what those are. Alright, Jacob, what is a sub 3? It is 5. Francesca, what is a sub 0? Negative 21. Very good. What is n? Amber? 3. Very good. Does anybody know what another term, what else could have I called a sub 3? Not a cubed. A. No, if we're going to put a number, it's going to be 3. But remember, it also could have been a sub n. If they say a sub n, because a sub n means your leading coefficient. So that would have been also 5. Alright. Questions? Alright. Let me figure out what I want you guys to do. So, and we're going to do quickly. This is page 615, and then 601. We will do J. All right. So, 615, I believe, is quite the same as what we just did in notes. So I am going to let you guys try to do those. But I do want to do some of 30 through 35 with you. And it's up to you on how you want to work it. If you want to work with me first and then come back and do these problems at home, it's up to you. I don't know how much time you'll have in class, but I do want to start 30 through 35 since you guys struggled with those. All right. Page 106 then.